This is Algebra 2 with Trig, Unit 5, Semester 2 exam review. So what we're looking at is question number 1, 81 to the 3/4 power. Multiple ways to do many of these. One thing that I would focus on is the denominators of 4. So you're looking at 1/4, and then you're going to cube that. Well, we know that 81 is broken into 9 times 9. And that's broken into 3 times 3 and 3 times 3. So this is really 3 to the 4th power. So 1/4 means the 4th root. This is the 4th root of 81. That is 3. Because 81 is made up of 3 times 3 times 3 times 3. 3 to the 3rd power. That should be 27. Number 2. Number 2 has this negative, and there's multiple ways that we could do this. We could distribute the negative into each one of these terms. But since this is just a -1, I'd suggest to just take the fraction and flip it. That'll use the negative. The negative is going to make every sign in here kind of the opposite of where it currently is. So that's going to bring the 16xy squared to the top, and the 4xy to the -1 to the bottom. Now it's time to try to clarify or simplify this. So the 16 divided by 4 becomes 4. The x's themselves will cross out. And you're going to bring a y to the 1st power up to the top with y squared already. So that's a total of y cubed. So that would be 4y cubed is that same value. Multiple ways to do that problem. That would be an obvious way to do it. Number 3, the square parentheses are not any different than the rounded, these brackets. But you can probably distribute in. The bases are not the same, so you cannot add exponents. The exponents are not the same, so you can't pull it out. So the best we can do is distribute in our exponent. So we get 3 to the 3rd times 4, 3 to the 6th. Well, an exponent of 3 over 3, that is just 3 to the 1st power, because that's a value of 1. And this is 4 to the 1/2 power. What is a 1/2 power? What is that actually doing? This is a decision making that you got to make. If you don't know what that means, you can't do this problem. It is a square root. So this is really 3 times 2, because it's a square root of 4. And our answer is 6. This one you could probably just type straight into your calculator, which would give you 6, because it doesn't have any variables with it. But over here, we start to get variables in it. We can't type that straight in our calculator. This is the cubed root. We're looking for 3 of a kind. Well, the cubed root of 8 is 2, because 2 times 2 times 2 makes 8. That's the cubed root of 8. I'm looking for 3 of a kind again. So I have 3 of a kind in this group. So I'm going to bring it out, but I'm also going to leave 1 of those x's still in the radical. If you're not quite sure what that means, I have 4 x's, x to the 4th power. I'm doing the cubed root of that. So I'm looking for 3 of a kind. That means I bring it out. And I have 1 left inside. Here I have 2 sets of 3 of a kind. So I have y squared, because I pull out 2 groups of 3 with no groups of 3 left over. So that would be my answer. You've got to have the index on your answer. The only thing in there should be an x. Here we need to be able to subtract two radicals. The radicals have to be identical. They are both to the third, they're both cube roots, so that helps, but this is 81 and that's just 3. Well, we've already talked about it. 81 breaks down into 9 times 9, which breaks down into 3 times 3 and 3 times 3. So this is 3 to the 4th power is 81. I'm looking for 3 of a kind like we just got done doing. So I'm going to bring a 3 out. And that's going to leave me a 3 inside. Minus. I already have a cube root of 3. Now this kind of looks like 3x minus 1x. That's 2x. So 3 cube root of 3 minus 1 cube root of 3 is 2 cube root of 3. Any questions about that? Okay, we jump down to number 6. Number 6 is the 4th root. So we're looking for 4 of a kind. So 32 is 16. That's 2 to the 4th power. This is the 4th root. 2 to the 4th power is 16 times an additional 2. You could plan it out like that if you can't visualize it. You have x to the 4th power and x to the 4th power and x to the 4th power and x to the 4th power with an extra x. That is 16 x's with an extra 17th x. We have y to the 4th, y to the 4th. That's 8 y's with 1 extra y. And then we're going to have a whole bunch of z's. Z to the 4th, z to the 4th, z to the 4th with 1 extra z. You definitely do not have to break it down like this, but I'm trying to show you why we're making the choices we are. You can try to visualize this. You can ask yourself, what's the 4th root of 32? Well, 16 is, the 4th root of 16 is 2. So we have an extra 4th root of 2 in there. How many times does 4 go into 17? Goes in there once, twice, 3 times, 4 times. So that's x to the 4th power. With 1 left over, so that stays inside the radical. You've got y squared with the y left inside. You've got z cubed with the z left inside. Now this is a funny looking notation wise. This 2, I believe this 2 is supposed to be an exponent. So what I notice is my bases are different. 56 and 7, they're different. But my exponents are the same. They're both 1/4. So if they're both the same, then you can pull those out as 1/4. And then you still have the square, which is going to multiply with that exponent. So this is 8 to the 2/4 power, which is 8 to the 1/2. So this is the square root of 8. The square root of 8 is 4 times 2. So that is 2 root 2. Okay, number 8. Just like we did in the previous problem, we cannot subtract these unless the radicals are the same. So I've got 3x cubed. Now this is the square root. This 3 is not saying it's a cubed root. It's not close enough. So this is the square root. Well, 125 is 25 times 5. And it has an x. And this is 4 times 5 with some x's left over. So I can take the square root of 25. I still have my x cubed. And that would leave me with a 5x left inside. I can take the square root of 4. 2, which is the square root number. 2 goes into this, or how many groups of 2 are there? There are 3 of them, with an extra x left inside and a coefficient of 5. So this is 15x cubed times square root of 5x minus 4 cubed root, or 4x cubed, sorry. So these are the same. That's a requirement. These variables are the same. That's a requirement to be able to subtract numbers. They're got to be like terms. So this is 11 x cubed square root of 5x. Here we're solving. So you have to think about what can you do first here. Do we take the 4 and the 5 and make 9? No, because this isn't really a 4. This is inside of a cubed root. So just like a normal algebra problem, you'd have to bring it across. Then we're going to raise it to the third power. That's how you get rid of a radical. You raise it to the power of the index. And that's going to leave you the 5x plus 4. Nothing gets cubed in there. The cube gets rid of the cubed root. And 1 times 1 times 1 is still 1. This looks like we're going to subtract it out. Subtract the 4 over. And that's going to be a negative 3, so this answer looks like negative 3/5. That's kind of weird. So we can test it. That's the great part about algebra. You can test so much of it. So I plug in my negative 3/5 in for x. That's 15 divided by 5 is negative 3. That's the cubed root of 1 plus 5. That's 1 plus 5. And yes, that equals 6. That's perfect. So we're going to move our constants over to the other side. Then we're going to divide. Then we're going to square both sides to get rid of a square root. Then we're going to add. Add the 2 across. So x equals 27. Graphing. In graphing, we're not going to really just go straight to this graph. You're going to start out graphing the cubed root of x. Well, you typically make a table of the parent function and the type of numbers you want a cubed root. Are -8, -1, 0, 1, and 8. The cubed root of -8 would be 2, and the cubed root of -1 would be 2, -1 and 0. So you can plot these out. And that's your graph, y equals the cubed root of x. That has a domain that goes forever right and left. And that has a range that goes forever up and down. That doesn't change at all. Now what we're going to do to every one of those points, we have the h value is 3. So we're translated 3 right and 2 up. That would be our translation. So we're going to take every one of these dots, 3 to the left and 2 up. 3 to the left, 2 up. So those are the new locations for the values. That's y equals, or f of x equals, the cubed root of x minus 3 plus 2. And that is our highlighted graph. So the range and the domain are still all real numbers. You can plug in any value of x and you can actually get any answer possible. You plug in the correct x, you can get that y value. So here, this is a square root graph. Well, you should know the square root graph is going to look like that. It's going to have the point of 0, 0. It's going to have the point of 1, 1. It's going to have the point of 4, 2. So what does this 2 do to the graph is the question. Is this an h value or a k value? This is a k value that is affecting it vertically. So this graph would be the square root of x plus 2. That's what that graph is doing. For it to come down and be opposite, it would actually have to be minus 2, and it would be that equation. For it to go left, the 2 would have to be inside the radical, and it would say minus. For it to move to the right, you would have to say plus 2 inside the radical. It's always the opposite for the h. Oh, no, I did that backwards. Opposite would mean plus 2, and that would take it to the left. Sorry. Got that straight. Saved. So, what is our domain for this? Well, a square root. What type of numbers can you type into a square root? Only values from 0 and bigger. We didn't translate to the left at all. And the range has to be bigger than 2. You can't get an answer smaller than 2. So that would be your domain and your range. So our answer is B. Last 2 questions. So just like any algebra problem, you move your constants together. Then we'll divide by 5. Now, how do you deal with an exponent of 3/4? We're going to raise it to the power of 4/3. Because that will make 12 over 12, which is a value of 1. Whatever you do to one side, you have to do the other side. So this is just x. Now, instead of 4/3, I don't really know what 8 to the 4/3 is. But if I took 8 to the 1/3, that's what this is. 1/3 times 4 is the same thing as 4/3. So I'm going to do 8 to the 1/3 and raise that to the 4th power. What is the 1/3 power of 8? That's going to be 2. 2 to the 4th power. 16. Now, if we would have had a half here, and we were taking half of some number, then we'd have to worry about plus or minus. But because it's an odd denominator, we don't worry about plus or minus. It can only happen with the positives. Last one. What am I going to do here? Can I bring the 3 and stick it under here with the 17 like terms? No. Making the decision is what this is all about. The math itself is simple. We're going to square both sides. We want to get rid of the square root. So we square both sides. And that leaves me with an x plus 7. And that requires me to do x minus 3 and x minus 3. Notice what I did here. I did not say x squared plus 9. It's not x squared plus 9. X squared minus 6x plus 9 when you get done foiling this out. So move your x over. Move your 17 over. And we factor it apart. It's got to be negative 8 and a positive 1. So I know my answers are 8 and negative 1. When you plug them in here, you have 8. That becomes 25. Square root of 25 is 5. 8 minus 3 is 5, so that worked. Check. Plug in a negative 1, that gives us 16. Square root of 16 is 4. When I plug in a negative 1, I get negative 4. So that's actually extraneous. So 8 is the only answer. I'm glad I checked that. A negative 1 would not produce a real statement. By squaring it, we kind of covered up and we created a possibility, a new dimension that created this x to the negative 1. X equals negative 1.